Good afternoon, good morning, and welcome to everybody that's joining us live online. I hope you took the opportunity for a nice break, as did I. Looking forward to the next set of sessions. I will be the moderator for the sessions. My name is Dr. Nick Van ter Hayden. I'm an emergency room physician by training. I'm also the incrementalist and a big tech aficionado. The first session we have is with Dr. Bipin Patel. He is from electronRx, and he's going to be talking to us about the power of digital biomarkers to revolutionize chronic care. Dr. Patel, over to you.
Thank you very much. Ladies and gentlemen, whoever's listening, morning, afternoon, or good evening, wherever you are. And Nick, thank you for having me on. So I would like to spend a few moments explaining and telling you what we're doing. So I'm a medical engineer by background. Have spent 30 odd years in the pharmaceutical sector, and I am a founder of two startup companies, both based in Cambridge, UK. The one we're talking about this afternoon or this morning is electronRx. We are figuring out how to empower patients and folks like Nick at scale. And we believe we've been figuring this out for a while, but we think we're almost there now to capture what are biological signals coming off from the physiology of an individual at scale. And we're interested in chronic diseases, interested in diabetes, hypertension, obesity, diseases which eventually get us as we get older. And I think there's an opportunity here for us to track those conditions, but also potentially predict the propensity to affect a particular individual because of their characteristics. So electronRx, we are a small group of people, about 20 employees full-time, based in Cambridge, working on technologies which enable us to capture physiological signals, primarily optical, acoustic, and motion. But right now, we're heavily leaning into the optical space. We've won a number of awards for being a great deep tech startup on several occasions, and we have our technology currently in the clinical environment. Several hundred patients have gone through the motion, and we've captured these signals, which then enable us to determine the state of their condition. So we tend to use the mobile phone is our basic platform. We tend not to use any bits of hardware that need to be attached to it, and therefore by now, most of you will probably recognize that the phones have lots of sensors, and we use those sensors, including the cameras, which are forward and backward facing. Just quickly moving on, I think the reason we exist and the reason that I get up at 5 in the morning and do the 18 hour shifts every day is we'd like to, I believe in making a small difference. And I think we can, because there's a massive opportunity with everybody, and probably everybody on this phone call, on the video call, has a mobile phone in the back pocket. And as you all know, masses of technology has gone in there, and it's a computer, as far as we can tell, and able to capture signals and then move them to somewhere safe, and then we can process them. So from that basic principle, we've spent the last 7 years getting to this, and we worked out how to do cardiorespiratory functions at absolutely scale by somebody simply holding their mobile phone in their hands and looking at it. At this point, I think I should say that this is a very simple example of what we're doing right now. We can capture things, very basic things, really, without any additional hardware, things around the heart and the respiratory function. Respiratory is where we are, so we are heavily involved in looking at changes that take place in asthmatics and congestive obstructive pulmonary disease patients who are at risk of hospitalization because of the fact that they'll get a flare up. And we've been working with a number of pharmaceutical companies to attempt to predict when or at what point are they